Hello everyone, how are you all? So I am back again with the topic of vectors and 3D geometry. So I hope आप vectors and 3D geometry का lecture number 1 देख के अब इस lecture पे आ रहे हो. If you are not watching and following the vectors and 3D geometry playlist का lecture 1 अगर नहीं देख के इस lecture पे direct आ रहे हो, then you won't be able to understand the basic concepts of what I have actually covered in the first video. आपको अगर लग रहा होगा कि मेरे को तो ऑलरेडी वेक्टर्स आता है, मैंने ऑलरेडी बेसिक्स ऑफ वेक्टर्स पढ़ रखा है फिजिक्स में, जैसे क्लास 11 का टाइम में जब फिजिक्स पढ़ाते हैं तो दे ऑलरेडी स्टार्ट विद द टॉपिक ऑफ वेक्टर. तो अगर लगता है कि वेक्टर्स आता है देन वाई विल आई वॉच दैट लेक्चर, देन आई वुड से ये जो स्टार्टिंग पार्ट है ना वो लगेगा कि इट इज़ ऑलमोस्ट सिमिलर टू दैट ऑफ द वेक्टर दैट वी स्टडीड इन फिजिक्स. ठीक है, बट यहाँ पर जो बेसिक अंडरस्टैंडिंग हो दैट विल बेसिकली ऑन द मैथमेटिकल पोर्शन ऑफ वेक्टर्स और ज़्यादा चीज़ हमने पढ़ने वाले. ठीक है, लाइक वी विल आई एम स्ट्रेसिंग मच ऑन द प्रॉपर्टीज़ एंड इंपॉर्टेंट क्वेश्चन एज वेल. वेक्टर्स इन 3D ज्योमेट्री काफ़ी ज़्यादा इंपॉर्टेंट चैप्टर है. अगर आप क्वेश्चन उठा के देखोगे ना तो काफ़ी ज़्यादा क्वेश्चन आ रखा है इस चैप्टर से. तो बाय दिस यू कैन सेंस द इंपॉर्टेंस ऑफ दिस पर्टिकुलर टॉपिक. So I hope you have attended the particular lecture number 1 and then are moving on to the lecture number 2. So with this, let us get started on the topic of vectors and 3D geometry. Okay, so my name is Sirsha and I am currently a BTech student at IIT Kharagpur. Okay, so today's goal will basically be on the understanding on the vectors. Okay, जहाँ से हम लोग लास्ट लेक्चर में एंड किए थे वहाँ से आज का लेक्चर को स्टार्ट करने वाले हैं. So we will be talking about vectors का brief discussion about more about vectors. We will talking about position vectors. We will also talk about section formula, midpoint formula and different questions which are actually related to that questions of triangles. Okay, लाइक आप बहुत ज़्यादा क्वेश्चन में देखोगे कि वेक्टर्स का क्वेश्चन में ऐसे इन्वॉल्व करके दे देगा कि ट्राइंगल का साइड दे देगा वेक्टर के टर्म्स में एंड द इंपॉर्टेंट पॉइंट्स उसको कोई एक वेक्टर पोजीशन वेक्टर से रिप्रेजेंट किया जाएगा एंड बेस्ड ऑन दैट कैलकुलेशन विल बी आस्क्ड इन द क्वेश्चन. तो ये वाला जो क्वेश्चन होता है वो बहुत ज़्यादा इंपॉर्टेंट क्वेश्चन होता है. तो आई होप आज के लेक्चर के बाद आप वो क्वेश्चन को अप्रिशिएट करोगे. देन वी मूव ऑन टू स्टडी ऑफ कॉम्पोनेंट्स ऑफ वेक्टर्स एंड देन वी मूव ऑन टू स्टडी ऑफ द बेसिक क्वेश्चन. तो कॉम्पोनेंट्स ऑफ वेक्टर्स एंड वी विल ऑल्सो स्टडी अबाउट लीनियर इंडिपेंडेंस, डिपेंडेंस एंड वी ऑल्सो स्टडी अबाउट लीनियर कॉम्बिनेशन ऑफ वेक्टर्स. ओके, सो शुरू करते हैं आज का लेक्चर. सो लेट्स गेट स्टार्टेड. लेक्चर को शुरू करने से पहले मैं सबसे पहले क्लियर कर दूं, आप एक रफ कॉपी लेके बैठो जिसमें आप रफ नोट्स बनाते रहो. ठीक है, साथ साथ जैसे लेक्चर का अंडरस्टैंडिंग चलते जाएगा तैसे तैसे आप शॉर्ट नोट्स बनाते रहो. ठीक है, नोट्स बनाते रहो. बाकी तो मैं नोट्स डिस्क्रिप्शन बॉक्स में प्रोवाइड कर ही दूंगा. ठीक है, सो आप लोग आई होप आप लोग नोट्स को डाउनलोड कर रहे हो लेक्चर डिस्क्रिप्शन बॉक्स से जाकर. ओके, टेक द गुड यूज़ ऑफ द पर्टिकुलर नोट्स फ्रॉम द डिस्क्रिप्शन बॉक्स. So with this let's get started. So today I will start upon the topic of position vectors. So basically why it is a very important concept whenever we study the concept of 3D geometry. 3D geometry में ना position vector का सबसे important concept बहुत ज़्यादा जगह में use करता है. ठीक है, so what is position vector? So if I say if O and I say it is a point, it is a fixed point, it is a point fixed in space and called origin. Okay, and if I say this is point which is fixed in space such that it is an origin point. Okay, and this point is a special point which is known as origin. Okay, for any space or any plane, then any point, for example I am representing the point in the 2D plane. Okay, फर्स्ट सिचुएशन आई एम टेकिंग दैट पर्टिकुलर पॉइंट इन द 2D प्लेन. ओके, अगर मैं 2D प्लेन में कोई एक पर्टिकुलर पॉइंट को रिप्रेजेंट करूँ, सबसे पहले 2D प्लेन आप बनाओगे कैसे ना, यू विल रिप्रेजेंट बोथ द एक्स एंड वाई एक्सिस. Okay, now this is basically XY plane. Now XY plane will be basically a 2D plane. Okay, now imagine the 2D plane as a sheet of a paper. Okay, so this will be a plane and it is a 2D plane, so it's sheet of paper, that is XY plane. Now in XY plane, if I consider any point, for example the point name is P. Okay, and this point has some coordinate which we are familiar with the study of coordinate geometry in class 11, that this particular point can be represented as x comma y. That means this is basically ordered pair, and this ordered pair actually represent the x actually represent the distance on the y axis. The distance on the y axis is represented by x and the distance from the x axis is represented by y. So if I say that this particular point in a 2D plane is represented as x comma y, and I have a point that is known as origin, that is basically 0 comma 0, that means this particular point is a reference point. If I take this point as a reference and I make a vector such that this point such that that is the head of the vector is pointing along P and the tail is along O, and this particular point is origin point, which is basically the intersection point of x and y axis, then this particular with respect to this reference point, whenever I make a vector which is pointing to that particular point in a 2D plane or in a space, then such vector is basically known as position vector. I hope this particular discussion is clear. Okay, now this is actually the vector which is known as position vector. ठीक है, तो पोजीशन वेक्टर समझ में आया होगा। एंड दिस पर्टिकुलर पोजीशन वेक्टर काफ़ी बार क्वेश्चन में आप देखोगे ना, पोजीशन वेक्टर को आर वेक्टर से रिप्रेजेंट किया होगा, ठीक है। तो दिस आर वेक्टर कैन बी रिटन एज ओपी वेक्टर, okay. So this particular thing is known as the from the origin now to the point is particularly known as the position vector, okay. Now if I say this particular point, so what can I represent this particular point? तो अगर आप बहुत सारा क्वेश्चन में आप देखोगे कि डायरेक्टली पॉइंट P को आप पोजीशन वेक्टर R से ऐसे रिप्रेजेंट कर दिया होगा, ठीक है। तो P ब्रैकेट में R वेक्टर से लिख दिया होगा, दैट सिंपली मीन्स दैट पोजीशन वेक्टर ऑफ पॉइंट, ओके, पोजीशन वेक्टर ऑफ point P is actually R vector. So from here I can say one important thing that the position vector of point P is known as R vector, ठीक है। तो अगर क्वेश्चन में अगर ऐसे रिप्रेजेंट करके दिया होगा, that simply implies this is the position vector, okay. Now let us move on and talk about some other important thing. Now अगर मेरे पास कोई दो पॉइंट है, for example in the XY plane, आई एम टॉकिंग अबाउट XY प्लेन इन दिस चैप्टर। आगे आने वाले चैप्टर में हम 3D प्लेन का भी बात करेंगे, एंड वेयर आई विल टेक अप द डिस्कशन कि 3D प्लेन में कैसे विजुअलाइज करेंगे इस चीज़ों को, ठीक है। सो वी हैव द चैप्टर विच इज नॉन 3D ज्योमेट्री। इन दैट पर्टिकुलर चैप्टर आई विल टेकिंग अप द डिस्कशन ऑन कैसे 3D प्लेन में एक पॉइंट को कैसे रिप्रेजेंट करते हैं। आई होप दिस डिस्कशन इज क्लियर, ओके। नाउ अगर मान लो मेरे पास दो पॉइंट्स है इन अ 2D प्लेन, द टू पॉइंट्स इन अ 2D प्लेन्स आर रिप्रेजेंटेड सच दैट बोथ ऑफ देयर पोजीशन वेक्टर्स आर नोन टू अस। अगर मेरे पास दो पॉइंट है जिसका कॉरस्पॉन्डिंग पोजीशन वेक्टर्स दे रखा है क्वेश्चन में, सो एंड देन वी आर एक्चुअली हैव टू कैलकुलेट द वेक्टर जिस जॉइनिंग द बोथ द पॉइंट्स, तो उसको कैसे करेंगे। सो let us talk about that particular discussion. Now for example we have a point which is in the 2D plane and its position vector is represented as a vector. So this is position vector, that means position vector का simple definition क्या है ना, कोई एक reference point लो, and the reference point for our definition case is always origin. एक reference point that is origin. So origin से कोई एक vector को कोई एक point से connect करेंगे, origin से उस point को connect करके जो vector बनेगा that is known as position vector. So if I say the point A has a position vector of A, then I can make this vector like this. So this is basically the position vector of point A. And similarly another point is given such that its position vector is V vector, and I can write like this, that this is a vector which is joining O and B in this particular fashion, but the head is along B. So if I have to find out this particular vector that is making this particular vector, okay, that is AB vector. So if I have to calculate the vector which is AB vector, and if it is asked in the question कि कैसे कैलकुलेट करें, आप बहुत बार देखोगे क्वेश्चन में आपको मेंशन कर दिया जाएगा कि पोजीशन वेक्टर दे दिया जाए, ठीक है। सो फ्रॉम हियर इफ़ यू आर गिवन इन द क्वेश्चन कि आपको निकालने पड़े कि ए बी का वेक्टर क्या होगा। अगर आपके पास दो पॉइंट्स है, दो पॉइंट्स का पोजीशन वेक्टर दे रखा है, तो व्हाट विल बी द वेक्टर ऑफ दिस पर्टिकुलर पॉइंट ऑफ द टू पॉइंट्स जॉइनिंग द टू पॉइंट्स। So what you have to do now, from here if I apply the triangle law of vector addition, so what can I see now? If I represent this AB vector, and what can I see now, this vector is actually A vector. So if I write this as A vector plus, from triangle law of vector addition I can write this as A vector plus AB vector is basically equal to B vector. Can I write this? Yes, I can write this from the triangle law of addition. What I said in triangle law of addition, एक वेक्टर का हेड को दूसरे वेक्टर का टेल से जोड़ो और जो रिजल्टेंट वेक्टर बनाओ सच दैट द टेल ऑफ द फर्स्ट वेक्टर जॉइनिंग द हेड ऑफ द सेकंड वेक्टर। तो ये वाला जो वेक्टर बनेगा दैट इज बेसिकली रिप्रेजेंट द समेशन ऑफ दिस टू वेक्टर्स बाय ट्रायंगल लॉ ऑफ वेक्टर एडिशन. So I hope this concept is clear. So from here what I can write that AB vector can be written as B vector minus of A vector. So from here I can write AB vector as B vector minus of A vector. So what does this particular thing actually implies? So this thing directly implies that this is basically the position vector of point B minus position vector of point A. So in order to get the vector joining the both the points, जिस point पे जा रहा होगा, अगर this is the final point, okay, this is the final position and this is the initial position, ठीक है, this is the final position and this is the initial position, and दो पॉइंट को ज्वाइन करके जो वेक्टर बनाएगा तो कैसे करेंगे दैट बेसिकली उसको क्या कर देंगे, जब पोजीशन वेक्टर ऑफ द फाइनल पॉइंट माइनस सब्ट्रैक्ट कर देंगे किससे ना, पोजीशन वेक्टर ऑफ द इनिशियल पॉइंट. आई होप दिस डिस्कशन इज क्लियर. सो फ्रॉम हियर व्हाट आई विल राइट, दिस इज बेसिकली पोजीशन वेक्टर ऑफ फाइनल, दिस इज बेसिकली पोजीशन वेक्टर ऑफ फाइनल माइनस पोजीशन वेक्टर ऑफ इनिशियल. आई होप यू अंडरस्टूड द डिस्कशन. नाउ मैं एक चीज़ क्लियर कर दूँ कि बिफोर स्टार्टिंग अबाउट द पोजीशन वेक्टर आई ऑलवेज टॉक्ड अबाउट देयर इज अ फिक्स्ड पॉइंट इन द 3D स्पेस. नाउ दिस पर्टिकुलर पॉइंट हैज़ अ पोजीशन वेक्टर विच ऑल्सो रिप्रेजेंट एज नल वेक्टर. ओके, सो बाय दिस यू कैन सेंस द नल वेक्टर का मैंने बताया था इन द प्रीवियस लेक्चर. आई हैव ऑलरेडी टॉक्ड अबाउट नल वेक्टर हैज़ इनफाइनाइटली मेनी डायरेक्शन. सो अगर कोई एक पर्टिकुलर पॉइंट लो ऑरिजिन, and from there I can draw infinite numbers of vectors. एंड उस पॉइंट से ज्वाइन करते किसी भी पॉइंट इन द 2D स्पेन अगर मैं कोई वेक्टर को बनाऊं देन सच वेक्टर विल बी कॉल्ड एज पोजीशन वेक्टर. तो अगर मैं इससे पूछूं कि व्हाट इज द पोजीशन वेक्टर ऑफ द ऑरिजिन देन आई कैन डायरेक्टली से दिस पोजीशन वेक्टर ऑफ ऑरिजिन इज बेसिकली नल वेक्टर. I hope this discussion is clear. Okay, so with this let us move on to the another important topic that is known as the section formula. अब बेसिकली सेक्शन फार्मूला आपने ऑलरेडी पढ़ रखा होगा इन कोऑर्डिनेट ज्योमेट्री. सो लेट मी ब्रीफ अपॉन दैट. फॉर एग्जांपल कोऑर्डिनेट ज्योमेट्री मैंने पढ़ा था कि आपने भी पढ़ा होगा, ठीक है, लाइक कोई एक पर्टिकुलर लाइन है, ओके, एंड आई विल टेक दिस पर्टिकुलर डिस्कशन ऑल्सो व्हेन आई विल स्टार्ट विद द टॉपिक ऑफ कोऑर्डिनेट ज्योमेट्री, ओके, द कोऑर्डिनेट ज्योमेट्री ऑल्सो. सो फॉर एग्जांपल देयर इज अ पॉइंट A which is represented as A comma B and another point is there which is B that which is represented as C comma D, and if I want to get another important point, let us represent as x comma y such that this particular point divides this line segment, this is obviously a closed point, so this is a line segment AB in the ratio m:n. Then I can write this point C का जो coordinate होने वाला है ना, that is x comma y can also be written as by section formula can be written as m times of C plus n times of A plus n times of A. This can be written as n times of A. Now from here divided by m plus n, comma, the y can be written as m times of D plus n times of B divided by m plus n. Now if I extend this particular discussion to the concept of vectors, I can write the section formula of the vectors in this such fashion like this, for example. And when we talk about section formula, there can be two types of division, that is one is internal division and another is external division. So this particular fashion of division where this particular point lies in between the 2 points, then such division is actually known as internal division of points. Now if the particular points lie outside the 2 points, the straight line which is joining the 2 points, that is A and B, then such division is known as external division. So in case of external division, we just do only one thing, that is in place of this plus sign we replace it with a negative sign. Okay, so I will take up the derivation of this particular formula when I will talking about the chapter of coordinate geometry. Okay, so for now you just remember the formula like this way, or I hope you have covered this particular formula in class 11 if you are a class 12 student or a dropper student. Okay, for class 11 students you can bear with me, and even this particular formula is also introduced in class 9th as well, I guess. Okay, so I hope you have covered in class 9th or in class 10th. Okay, so from here if I say internal division of vector, so for example if I take two position vectors, okay, for example there are 2 points and the position vector of this particular point is represented as A vector of this point A, and point capital B is represented as B vector, and this particular point is known as the origin. If I say this particular point is origin, then you will say this A vector is basically the point, the vector which is joining this O point with this A point, and similarly B vector is basically the point which is joining this B point with this O point. Okay, I hope this particular thing is clear. Now because this particular thing is basically a position vector. अब position vector का मतलब क्या होता है कि origin से उस particular point को जोड़ दो और जो resultant vector आएगा that is known as the position vector. So if I say and if I join this particular triangle, if I complete this triangle such that this is the AB line, and if I want to find out another position vector of a point C, okay, if I want to find out a position vector of point C and I represent as position vector as C, okay, C vector, and such way that this particular point C actually divides this particular vector, or if I say this particular line segment in the ratio m:n, then I want to get to the position vector of point C. How can I do so? So similar to the concept of section formula, I can add, this is a basically internal section formula, internal division of section formula. So from here I can write this C vector can also be written as m times of ना m को किससे मल्टीप्लाई करो, ऑपोजिट से, एंड n को इस ऑपोजिट से, इसके ऑपोजिट से n को मल्टीप्लाई करो, और m को इसके ऑपोजिट से मल्टीप्लाई करो. सो m टाइम्स ऑफ b वेक्टर प्लस ऑफ n टाइम्स ऑफ a वेक्टर डिवाइडेड बाय m प्लस n. So from here you will directly get to the result of position vector of point C. So from here you will directly get to the result of position vector of point C. Now there is a special case. Now if I say this C is basically midpoint of the line segment AB, that means the vector AB का अगर C is the midpoint, then what can I say that m and n are equal and is equal to 1. Okay, अगर m और n अगर equal है and they are equal to 1, that is 1:1 ratio में divide कर रहे हैं, then in such situation I can tell the C point is basically the midpoint of this AB vector or AB line segment. In that particular scenario I can calculate C vector is basically equal to A vector plus B vector divided by 2. Okay, so this is basically a special case of the section formula. This is basically a special case of section formula, and which is also known as the midpoint formula in the coordinate geometry. Okay, so this is also known as the midpoint formula in coordinate geometry. So if I talk about and write this for internal division, okay, now similar to the result of internal division, if I write the formula for external division, what changes will I see? Now for external division, okay, if I write the formula for external division, I will see only a change in the formula in such a fashion that m times of b vector, and instead of this plus sign I will replace with the negative sign, minus of n times of a vector divided by this m minus n. Okay, so from here I will get the external division, that is a point C. अगर point C externally divide कर रहा है the line segment AB, then I will get the result over here as negative over here. And if it is dividing in the internal fashion such that the point lies inside the line segment joining both the points, then in such case I will say it as internal division. I hope this discussion is clear. Okay, so okay, with this let us move on and try some of important questions. Okay. Now basically if I say in such a fashion, I will take one example problem to illustrate my sayings. Okay, now if I want to say that there is a triangle, okay, in a triangle such a triangle is given such that ABC is a triangle, okay, and if I say that G is basically the centroid of the triangle ABC, if I say there is in a triangle ABC the G is the center of the triangle ABC, and let us draw the triangle in this way. Okay, so if I have a triangle over here, it is very good practice to basically represent all the points of this triangle by position vector in while solving question on vectors. अगर vector question दे रखा होगा and पूछ रहा कोई particular fixed point of a triangle and they are involving calculation in that, in such case you कोई भी point को inside the triangle या फिर outside the triangle को origin मान लो and corresponding all the points उसको एज्यूम कर लो कि वो पोजिशन वेक्टर को बाय दिस बी वेक्टर एंड सी वेक्टर एंड okay in such fashion. Okay, now while you are doing so and there will be a point which is known as a centroid point. Okay, centroid क्या होता था? A centroid is basically the point of intersection of median. What is median? Median is basically a line segment joining the point to the midpoint of the opposite side of that particular point. So for this particular point A, if I join a line segment such that it is joins the midpoint of BC, that is D, if D is a midpoint of BC and such a line which joins A and D, then in this particular line it is known as a median line. And similarly all the median line, the point of intersection of all the median line will basically form an important point that is known as a centroid point. So if I say G is the centroid, corresponding to this I assume the G vector as the position vector of this centroid. Okay, so from here what can I go on and write? Okay, so if I see, what can I see from here, that AD is basically the midpoint, basically this D is the midpoint of B and C. So if I say this A vector, and let us assume this A vector as origin, if I assume this A vector as origin, so for example I let this A vector as origin, then I can write this B point as position vector of B is basically B vector is like this, and similarly the position vector of C as like this vector. And similarly if I want to know about the position vector of point D, then I can write the position vector of point D same to this as B vector plus C vector divided by 2. I hope this discussion is clear. So if I change the notation and write in terms of G, so can I write like this, that GD vector is basically equal to GC vector plus GB vector divided by 2. Because if I consider this smaller triangle, from here, if I consider this small triangle, okay, and represent this vector as GB vector and GC vector by the concept of position vector, okay, this is actually GB vector and this is GC vector, then can I write the GD vector basically, because GD vector the D point divides the line BC in equal portions, so can I write the position vector or the vector of GD as GC vector plus GB vector by 2. So if I take this 2 on this particular side, can I write it like this, the 2 times of GD vector is basically equal to GC vector plus GB vector. So if I am asked, and in the question, in the given example, it was asked to calculate the value of GA vector plus GB vector plus GC vector. Okay, So in this particular question, it was actually asked to calculate the value of this particular vector addition. So in order to compute this vector addition, what I found from here, so if I do that, this is basically GA vector, and G vector plus GC vector is basically 2 times of GD vector. Okay. So from here I also know one important formula from the concept of triangle. Basically this particular concept of triangle was actually introduced in the class 9th. Okay. So if I know that if AD is basically the median, then we know that the point G, that centroid, actually divides the median in basically the ratio that is 2:1. So from here what can I go and write? I can go on and write this particular point, that is a G divides the point AD in the ratio 2:1. So if G divides the line AB in the ratio 2:1, I can use the section formula and can write 2 times of GD, 2 times of GD vector is basically equal to minus times of GA vector. Okay, how can I do so? So if, for example, if I take any particular point as origin, so if I want to write this GA vector basically will be GA vector will basically be like this. Okay, GA vector, and I have to relate with GD vector. Okay, the GD vector in this particular direction. So if I see that these two vectors are actually in anti-parallel direction, and this particular direction जो जितना length है, that is basically 2y times of this particular direction, and from here I also see the direction is basically anti-parallel. So both of the vectors are unlike vectors, or basically in the opposite sense of direction. So I cannot write like this, that 2 times of GD vector is basically equal to negative of minus of GA vector. I hope I can write like this, because GD जो लेंथ है that is basically twice, अगर GD का लेंथ का जो twice कर लेते हैं that is basically equal to GA का लेंथ. The GA का length is basically twice of GD का length. So from here I get the magnitude as 2 and the direction is basically negative of them because they are anti-parallel. So when I write like this, the 2 times of GD vector is basically minus of GA vector. So if I replace this 2 times of GD vector as minus of GA vector, so what the result will I get? I will get nothing but this is known as a null vector. So from here I got an important conclusion that if in a triangle the G is the centroid point of this triangle ABC, and if I make the vectors corresponding to joining all the points from G से अगर हर एक पॉइंट को ज्वाइन करके वेक्टर बनाएंगे, that is GA vector plus of GB vector, and then I add those vectors GC vector, then I will get the result as null vector. Now this is very an important result in a triangle. Is very important result in a properties of triangle. Okay, so I hope you understood this particular discussion. So with this, let us solve an important question which came up in the year of 2023 in the JEE mains paper. Okay, so this question is very important types of question. Now these types of questions are very useful for your exam preparation. Even this type of question, एक ऐसा भी क्वेश्चन आया था जहाँ पर आपको रिलेट कर किया था, एक ट्राइंगल का वेक्टर्स देके दे रखा था, and the vector equations were given. From those vector equations you have to choose that a particular point represent which kind of point, circumcenter, orthocenter, incenter या फिर centroid. So all the important points of a triangle you must have a very good understanding. अगर नहीं पता होगा तो डायरेक्टली गो टू द वेब एंड सर्च फॉर इट, अगर नहीं पता होगा. ठीक है, मैं तो कोशिश करूंगा कि सर्कम सेंटर, ऑर्थो सेंटर और सेंट्रोइड क्या होता है मैं सब कुछ बताने का कोशिश करूंगा. लाइक सर्कम सेंटर इज बेसिकली द पॉइंट ऑफ द, अगर आप एंगल बाइसेक्टर लेते हो हर एक पॉइंट का कॉरस्पॉन्डिंग, देन यू गेट द पॉइंट ऑफ इंटरसेक्शन एज सर्कम सेंटर. एंड अगेन ऑर्थो सेंटर इज फॉर्म बाय द परपेंडिकुलर फ्रॉम ऑल द पॉइंट्स टू द ऑपोजिट साइड, एंड द पॉइंट ऑफ इंटरसेक्शन ऑफ ऑल द परपेंडिकुलर्स or from all the points basically represent the orthocenter, and similar to that the point of intersection of all the median will basically give the centroid. Okay, so question में क्या बोला है कि if point P and point Q respectively are basically circumcenter and orthocenter of a triangle which is represented as ABC, and if you have to find this particular result, that is PA plus PB plus PC. अगर आप डायरेक्टली इस क्वेश्चन को जंप ऑन करने जाओगे बाय ट्राइंगल, सिंपल लॉ ऑफ ट्राइंगल से डायरेक्टली क्वेश्चन करने जाओगे, यू विल डेफिनेटली स्टक इन दिस क्वेश्चन, यू विल डेफिनेटली गेट स्टक इन दिस क्वेश्चन. इस क्वेश्चन को करने का एक सिंपल तरीका है दैट यू हैव टू अंडरस्टैंड. सबसे पहले लेट मी टेक अप वन important note that you have to know from this before solving this question. Now in the previous question, in the previous example I talked about that a centroid divides the median in the ratio 2:1. Now similar to that particular fashion, we also have another important result, that is basically if you in a median, okay, this circumcenter, centroid and the orthocenter are all lie on a same straight line, and that they all lie on the same straight line. And if they lie on the same straight line, there is another important property that if G is represented as centroid and O is represented as circumcenter, or let me write C as circumcenter, okay, for better understanding. Okay, and if C represent the circumcenter and O represent the orthocenter, then in particular situation the point G actually divides this line segment joining OGC, this OGC line in the ratio 2:1. I hope this particular concept is actually known to you from the concept of properties of triangle, which you already have studied in the junior classes. In class 9th, I guess you have studied all these particular properties of a triangle. Okay. So with this, let us move and try to solve this question. So what is given in the question? The question says that there is a triangle, and the triangle is represented as A, B and C. Okay, and there are points. Okay, there are points. This particular point is basically, the point P is basically circumcenter, and the point O is basically the orthocenter. And if I say that this is point G, this is a centroid point of this triangle. So from the centroid point, what I actually have got an important result. I can also write the centroid point basically as, the centroid point can also be written as, if I want to write the centroid point. And for that, before starting on the question, and let us talk about the discussion of position vector. So for position vector, I need a reference point. So let us take the P as a reference point. Okay, P as the reference point. So, and if I take P as a reference point, that is an origin. So it represent the P as origin. So if I say P is the origin, so what can I write about the centroid? I know an important result of centroid is basically the PG vector will basically be equal to the PA vector, there is a position vector of point A plus position vector of point B plus position vector of point C divided by 3. Okay, now this result actually comes from the section formula. Okay, now this particular result is basically important result. I hope you have covered this particular result when you are actually talking about solution of triangle. अगर नहीं भी कर रखे हो तो डायरेक्टली रिमेंबर द रिजल्ट फॉर नाउ, फॉर द टाइम बीइंग यू रिजल्ट रिमेंबर द रिजल्ट. सॉल्यूशन ट्रायंगल मैं बहुत डिटेल में कवर करूंगा विथ ऑल द डेरिवेशन एंड इंपॉर्टेंट प्रॉपर्टीज. ठीक है, सो दिस पर्टिकुलर रिजल्ट एक्चुअली कम्स फ्रॉम द कॉन्सेप्ट ऑफ ट्रायंगल ओनली. अगर आप क्लास 9th में ये वाला कॉन्सेप्ट पढ़ रखे हो देन इट विल बेसिकली ईजी हो जाएगा. ठीक है, एंड अगर आप देखना चाहते हो कैसे आता है, बेसिकली अगर मैं पूछूं कि सेंट्रॉइड पॉइंट को कैसे निकालोगे फ्रॉम द स्टडी ऑफ कोऑर्डिनेट ज्योमेट्री, इफ आई वांट टू नो कि अगर एक्स वाई जेड का पॉइंट दे रखा हो. Okay, for example, the point A, the coordinate of point A is given, point B is given and point C is given. Then if I say that write me the coordinate of the point of the centroid, then what will you do? You will add all the x coordinate and divide by 3, and for the y coordinate you will do, you will sum of all the y coordinate and divide by 3. In such fashion you will get the centroid. And similar to that, if I say that PG vector is basically the position vector of centroid, then can I write the centroid vector as something like this, a position vector of point A plus position vector of point B plus position vector of point C divided by 3. Now why I say this is position vector? Because P is taken as the reference point, which is the origin. So from here I get an important result, that is 3 times of PG vector is basically equal to PA vector plus P vector plus PC vector. Now I can do this particular question in this particular fashion because in the question it is nowhere mentioned about the concept of the origin. So I can take my origin in my own sense to solve the question. मैं origin को कहीं भी ले सकता हूँ. ठीक है, so it is my own choice कि मैं origin या फिर reference point कहाँ लेता हूँ. But once you choose the reference point, it is fixed for the whole question. एक बार रेफरेंस पॉइंट चूज कर लेते हो देन इट इज ऑब्वियसली फिक्स्ड फॉर ऑल द क्वेश्चन. आप फिर से सेम क्वेश्चन के लिए चेंज नहीं कर सकते हो. सो इफ आई एम टेकिंग पी एज अ रेफरेंस पॉइंट फॉर दिस पर्टिकुलर क्वेश्चन, आई वोंट बी चेंजिंग दिस पॉइंट पी एज अ रेफरेंस फॉर एनी अदर पर्टिकुलर पॉइंट. एंड व्हाट आई गो ऑन एंड सी in order to calculate the position vector of point A plus point B plus point C, what I see this is basically the result which is asked in the question. यही क्वेश्चन पूछा था. सो फ्रॉम हियर आई हैव टू चेक ऑन द रिजल्ट. अगर मैं रिजल्ट में देखूँ ना तो यहाँ पर पीजी का कोई टर्म मेंटेन नहीं किया है. ठीक है, दैट जी पॉइंट तो बोला ही नहीं है. सो आई हैव टू टेक द पॉइंट इन द नोन क्वांटिटीज, दैट इज पी या फिर क्यू पे रिप्रेजेंट करना होगा. सो व्हाट कैन आई डू? आई कैन टेक दिस इंपॉर्टेंट रिजल्ट, दैट इज द, अगर मैं बोलता हूँ दिस पॉइंट इज पी, दैट इज अ सर्कमसेंटर, and this particular point is G, that is a centroid, and this particular point is Q, that is a orthocenter. This is basically the ratio is 2:1. The 2 is over here, the orthocenter से जो centroid का distance is 2 and circumcenter से centroid का distance is 1 times. Okay, so from here what I get, I can write this PG vector. Okay, PG vector is basically the position vector of point G. अगर मैं पूछूँ position vector of point G, आप क्या बोलोगे? That is basically the position vector of point P plus 2 times of position vector of point P plus 1 times of position vector of point Q divided by 3. अब बोलोगे यही बात. अगर मैं पूछूँ position vector of point P क्या है, आप क्या बोलोगे? द पोजिशन पॉइंट वेक्टर इज बेसिकली द रेफरेंस पॉइंट. तो मैंने बताया था कि अगर किसी पॉइंट को रेफरेंस माना जाता है उसका पोजिशन वेक्टर क्या होता है? दैट इज बेसिकली नल वेक्टर. सो आई विल रिप्रेजेंट विद 0, दैट इज नल वेक्टर. ओके, सो बेटर होता है कि नल वेक्टर से रिप्रेजेंट करो. तो 2 टाइम्स नल वेक्टर इज नल वेक्टर ओनली. प्लस पोजिशन वेक्टर पॉइंट क्यू क्या है? पोजिशन वेक्टर ऑफ पॉइंट क्यू बेसिकली पी क्यू है, पी क्यू divided by 3. So from here what I get, that basically 3 times of PG vector is basically equal to PQ vector. Now from this both the result, this first equation and the second equation, on comparing on first equation and second equation को compare करता हूँ from first equation and second equation, what I get the result as, what result I get, result क्या मिल रहा है यहाँ से, क्या मिल रहा है कि the result that is PA vector plus PV vector plus PC vector is basically equal to PQ vector. Okay, so from here I get the correct option to this, and the correct option to this particular question is basically option number B. Okay, so I hope this particular discussion was clear. Okay, so let us move on to the next question and study about the next concept, that is basically the concept of linear combination of vectors. So whenever, for example, in order to study the linear combination of vectors, let us introduce and this is basically a simple thing only. Now when I say about linear combination, this basically means the all possible combination that can be expressed as a summation or a subtraction of any multiple number of vectors. Any particular vector can be represented as scalar times of addition or subtraction of many number of n number of vectors. So if I say there is a vector r, okay, this vector r is said to be linear combination of, and I have many number of vectors such that if I have 3 vectors such that A vector, B vector and C vector, then if I say R can be represented as linear combination of A vector, B vector and C vector and so on, then I can write this particular vector equation as R vector is basically some scalar multiple of A vector plus some another scalar multiple of B vector plus some scalar multiple of C vector and so on. If I say there are many number of vectors, so from here I can write this R vector. If I say this R vector is can be expressed as linear combination of A vector, B vector and C vector and so on, then I can write this particular vector equation as R vector can be directly represented as x times of A vector plus y times of B vector plus z times of C vector, where these x, y and z are all basically real numbers. Okay, are all basically real numbers. So if I have to represent any particular vector, so for example if I have a vector like this, A vector plus 2 times of B vector is basically equal to C vector. So from here I can say an important thing, that the C vector can be represented as linear combination of A vector and B vector. I hope this particular discussion is clear. Okay, now let us move on to the study another important topic of vectors, that is basically collinear and non collinear. Now ये वाला जो concept है ना, ये बहुत ज़्यादा क्वेश्चन में दे देगा, ठीक है, आपको बोला जाएगा कि the points given in the vectors as a represents vectors are collinear vectors and you have to find out some unknown quantities resulting this. तो कोलिनियर पता ही नहीं है तो नॉन कोलिनियर या कोलिनियर पता ही नहीं है तो आप क्वेश्चन को सॉल्व नहीं कर पाओगे. तो दिस वेरी इंपॉर्टेंट टॉपिक. व्हाट इज मीन बाय कोलिनियर? कोलिनियरिटी क्या होता है? अगर आप स्ट्रेट लाइन पढ़े हो तो यू नो दैट 2 पॉइंट्स हमेशा कोलिनियर होता है. एंड इफ आई हैव एनी 3 पॉइंट्स, ओके, इस 3 पॉइंट्स को कोलिनियर तभी बोला जाता है इफ दे लाई ऑन द लाइन सेगमेंट जॉइनिंग द 2 पॉइंट्स. फॉर एग्जाम्पल इफ आई हैव अ पॉइंट एज ए एंड बी एंड आई से द सी इज कोलिनियर विथ ए बी. If I say C is collinear with AB, then I have to mention that AB का जो लाइन बनेगा, AB से पास करने वाला जो लाइन बनेगा, CB उस लाइन में जब पार्टिसिपेट करेगा. Similarly, if I say it is non-collinear, so if I have 2 points, 2 points are always collinear. 2 points are always collinear क्योंकि 2 points से there will be always a straight line that will exist. Okay, so 2 points से अगर मैं straight line बना सकता हूँ, obviously मैं बना सकता हूँ. So if they have a C point, which is that from here I can see that C point is non-collinear to this particular line because it doesn't lie on this particular, because there cannot be any straight line which can contain all the 3 points together. I hope this discussion is clear. So from here let us introduce the concept of vectors to collinearity and non-collinearity. ओके, क्वेश्चन में काफ़ी जगह कोलिनियर नॉन कोलिनियर क्वेश्चन होगा, ठीक है, एंड वी ऑल्सो टॉक अबाउट दोस क्वेश्चन ऑल्सो. ओके, सो इफ आई हैव 2 वेक्टर्स सच दैट A vectors and B vector are given as 2 vectors and I say these 2 vectors are collinear. If I say these 2 vectors are basically collinear vectors, then what can I write? If I have these 2 vectors as collinear vector, then what can I write? Now for example, if there is an x unit vector which is in the direction of A vector, then this x unit vector can be represented as A vector divided by modulus of A vector from the last class discussion. Okay, so from here I can say that there is an x cap which is basically in the direction of A vector. Okay, then another unit vector will exist which is also an x vector. Okay, which is also an x unit vector which is in the direction of B. Okay, so I hope this particular concept is clear. मैं क्या बोल रहा हूँ फिर से मैं रिपीट कर रहा हूँ माई वर्ड्स. ओके, there is a unit vector which is known as x in the direction of a vector, then if I say that a and b are collinear vectors, then there will also exist another vector, and which is none other than the same x vector, which is none other than the same x unit vector, which is also in the direction of b vector, which will be also in the direction of b vector. ठीक है, अब डायरेक्शन ऑफ बी वेक्टर बाय डायरेक्शन आई मीन टू से पैरेलल भी हो सकता है, एंटी पैरेलल भी हो सकता है, पैरेलल भी हो सकता है, ओके, दे माइट बी ऑन द सेम लाइन ओनली, ओके, पैरेलल डायरेक्शन में भी हो सकता है, एंटी पैरेलल डायरेक्शन में भी हो सकता है. सो देयर कैन बी प्लस माइनस साइन इंट्रोड्यूस होगा, सिर्फ एक प्लस माइनस साइन ही इंट्रोड्यूस होगा. सो फ्रॉम हियर आई कैन राइट दिस ए वेक्टर इज बेसिकली इक्वल टू मॉड्यूलस ऑफ ए वेक्टर टाइम्स ऑफ एक्स यूनिट वेक्टर. Okay, so from here if I say that b is also collinear, I can write b vector as b vector का modulus plus minus times of x का unit vector. So I hope this particular thing is clear. I hope this thing is clear. Okay, so if I say that a vector and b vector are collinear, then I can write their collinearity relation something like this. So if I have to introduce both the relation between both the vectors, what can I go on and do so? So I can write this a vector will basically represented as, this a vector can be represented as modulus of a vector, okay, divided by modulus of b vector. If I take out this divide this both the vectors, and I write this modulus of a vector divided by modulus of b vector, and then multiply with the modulus of b vector, and then modulus of b vector. This is basically a scalar quantity. So from here, and then I can write the x unit vector. What I did from this first equation, I only multiplied by b vector ka modulus, and in order to multiply I have to divide, okay, to have the nullify them. Okay, so I multiply as well as divide the by the modulus of vector b. So from here what can I introduce and write this a vector will be basically equal to plus minus times of a vector divided by b vector का modulus into, और ये वाला चीज़ क्या है, basically if I introduce a plus minus sign over here, then I can represent plus minus over here also. So if I say plus minus here, I have to write minus plus over here to incorporate the result. But if I say this is also plus minus only, and then can I write this result as b vector का modulus plus minus of b vector का modulus times x unit vector can be represented as b vector. So from here I got an important result that अगर दो वेक्टर एक कोलिनियर है, अगर दो वेक्टर एक कोलिनियर है, then there will be a linear relation between these two vectors. That means that can be expressed in terms of if I express in terms of linear combination in such a result, that this result can also be written as, so if I assume this particular constant as lambda, then can I write this as vector is basically equal to plus minus times of lambda times of b vector. Okay, plus minus because of we are not sure which sense in direction of p is there, but I can write like this fashion for some scalar. Okay, so from here I get an important result that if a and b vector are collinear, I can write this as a vector is basically equal to lambda times of b vector from some scalar which is non-zero or maybe 0 or any scalar, or this can also be written as b vector is equal to lambda times of a vector. I can also write this particular relation. I can write this relation, or I can write this particular relation. So from here I get an important result that is of collinear and non-collinear. Okay, so with this let us try and understand another important theorem about collinearity. So before solving this particular question, let us try and understand an important theorem on collinear. So and now let us try and understand what is non-collinear. So if I have these two vectors, vector a and vector b, and I say these two vectors are non-collinear vectors, if I say these two vectors are basically non-collinear vectors, these vectors are basically non-collinear vectors, then in such situation, and I have the two scalars x and y are basically scalar quantities. These are vector non-collinear vectors, and x and y are scalar quantities, and if I am given with this particular linear combination relation, x times of a vector plus b times of y times of b vector is basically equal to null vector, then in this particular linear combination, if they are both the vectors, that is a vector and b vector, are non-collinear, in this particular situation what can I go on and say that directly x and y are equal to 0. Both of them are equal to 0, because there won't be any linear relation, between these two vectors. If I have the two vectors which are non-collinear, then there must not exist any linear relation between these two vectors, and in this case if there is no linear relation between two vectors, it can only possible that is equal to null vector only and only when x is equal to 0 and y is equal to 0. So this particular theorem is very important. So what can I go and write this, because from here if I try to find some linear relation, this basically a vector is basically equal to minus of y by x times of b vector, and if I say that a vectors and b vector are non-collinear, then this particular condition will be equal to 0. This particular condition will be equal to 0, and if I say that both the points are non-collinear, so this is basically a contradiction to this particular fact. if I say this both the points are non-collinear, then if I can, and then I can represent this vector as this particular fashion, then this is basically a contradiction which arises to our concept. This is basically a contradiction which arises to the concept that because if I can write a vector some scalar times of b vector, then these are basically a vectors and b vector are collinear vector, but we say that a and b vector are non-collinear vector. So this is basically a contradiction. So this can be only be true, this can only be true when x is equal to 0 and y is also equal to 0. So this can only be true when x is equal to 0 and y is also equal to 0. So I hope you will take this particular thing in mind. Okay. So with this, let us try and calculate this particular question. Let me rub this particular thing. I hope you have taken down the notes. Okay. Go on making important notes from this particular lectures. Okay. Okay, I am trying to my best to explain the particular thing in very short and get understanding. Okay, so that you develop a good understanding. And notes तो अच्छे से बनाते रहो, ठीक है. Notes के लिए तो मैं PDF provide कर ही रहा हूँ. After the lecture is over, in the description box I am providing the notes also. So from the notes you try out and make some good note. अभी के लिए आप rough notes बनाते रहो, क्वेश्चन को रफ कॉपी में सॉल्व करते रहो मेरे साथ साथ, ठीक है. So in this question, this is basically JEE. तो 2004 में तब JEE मेंस जो एग्जाम होता था उसको JEE एग्जाम बोला जाता था. दैट इज बेसिकली ऑल इंडिया इंजीनियर एंट्रेंस एग्जामिनेशन. So from this question, what is given that there is 3 position vectors, or if I say these 3 vectors are given as such that a vector, b vector and c vector are 3 non-zero. These vectors are non-equal to 0. This modulus of these vectors are non-zero vectors. There is basically non-zero vectors such that no 2 of them are collinear. No 2 of them. That means their a and b are non-collinear, b and c are non-collinear, and c and a are non-collinear. So if I have given 3 vectors such that no 2 of them are collinear, then and it is also given in the mention in the question that a vector plus 2 times of b vector is basically collinear with c vector. It is said in the question. So from here I can write if there is a collinearity relation between a plus 2b times vector is some collinear with c vector, then I can write this as lambda times of c vector and represent this as first equation. Similarly, if I go on and see this, there another vector, that is b vector plus 3 times of c vector is given as it is collinear with a vector. So from here I can write this as mu times of a vector. So for here the lambda and mu are basically real value of scalar. Okay, from some real value of scalar. Okay, so from here what I can do one important thing, that is basically if I have to find out the result, that is basically a plus 2 times of what is given in the question is basically we have to find out a plus 2 times of b vector plus 6 times of c vector. So how to get that particular result? If I have to calculate this result, then what can I go on and do? I can see one important thing. Okay, what can I do from here? I try and simplify this result as if I multiply the equation 2 by the scalar number which is 2, I can do it because there exists a collinearity relation. So from here if I multiply that number 2 which is a scalar to this particular vector, and I do one important thing, that is from equation 1 I subtract 2 times the equation number 2. So from here what will I get? If I multiply this equation with 2, so what will I get? This will be 2 times of b vector plus 6 times of c vector is equal to 2 times of mu times of a vector. So from here what I can, and if I subtract this particular result, I will get the result as a vector minus 6 times of c vector is basically equal to lambda minus 2 times of lambda times of c vector minus 2 times of mu times of a vector. Okay. Now from here we also know an important relation. We know an important relation if what we are given also in the question, that is a vector and c vector are non-collinear vector. So if I say any vector, this is another vector, can be represented, this particular vector can be represented as linear combination of these 2 non-collinear vectors? It can never be possible. So in that particular scenario what have to be true? This particular case can only and only be true when lambda is equal to 0 and mu is also equal to 0. Okay, so from here if I see and get if lambda is equal to 0 and mu is also equal to 0, so I can write this particular thing in this particular fashion as this particular, it can also only be true when lambda is equal to 0 and mu is equal to 0. Or if I go on and explain in another terms such fashion that what is given actually in the question as basically a vector plus 2 times of b vector, which is basically this particular thing, plus 6 times of c vector. Okay, so what can I go on and do? One important thing, and if I add from a vector plus 2 times of b vector, if I add 6 times of c vector, I get what is actually asked in the question, and this can be represented as lambda plus 6 times of c vector. So from the question we already know one important thing, that that from here actually we got the important result. Okay, this particular result can also be represented as lambda plus 6 times of C vector. Also from here, if I add the A vector, if I multiply this with 2 times and add A vector, I can also write this as A vector plus 2 times of B vector. From equation number 2, I can write this as 6 times of C vector is basically equal to 2 mu plus 1 times of 2 mu plus 1 times of A vector. Can I write like this? And if I write like this, these particular things are both are same thing. Then if these both things are same, I can represent these both the things as same, and then I can write this as lambda plus 6 times of C vector is basically equal to 2 mu plus 1 times of C vector. Okay, if I erase this, basically this is not wrong result I got over here. Okay, I am sorry for that. So from here, if I see from here, then I can get this both the results are same, that is A plus 2b plus 6 times of C vector is basically lambda plus 6 times of C vector, and this can also be represented as 2 mu plus 1 times of A vector. Then if this both the results are same, then this result is also equal to this result. So from here, if I compare this both the result, and if I say this is basically 2 mu times of A vector, so and also I know that A vector and C vector are non-collinear, then there won't exist any collinear relation. Okay, collinear relation. In such case, lambda plus 6 का वैल्यू जो होगा दैट इज बेसिकली इक्वल टू 0 एंड म्यू plus 2 mu plus 1 का जो वैल्यू होगा that particular value will be 0. From here I will get the value of this particular case, because if this particular thing is 0, so from here I get the result as basically equal to 0 times of A vector basically equal to 0 vector. Or if lambda plus 6 is equal to 0, then if I multiply 0 with C vector, I get the result as 0 vector. So from both the situation I am getting the 0 vector, and that will be the required answer to this particular question, which is actually asked in JEE mains 2004. So this particular question, the answer होगा 0 vector. Okay, so this is very important question, and this type of question can come repeated in some other form also. I hope this particular discussion is clear. Okay, with this let us move on to the other important topics. Let's move on to the next topic, and that is basically the concept of components of vectors. So if I talk about component of vector, so what is basically mean by the component of vector? So any vector, for example, I have a vector, let me write. Okay, so if there is a vector A vector such that, and there are other two vectors which are represented as B vector and C vector. Okay, now C vector and B vector can be any type of vector. Okay, so if I want to know the component of vector, that is basically mean the projection of that particular vector on that particular vector. Okay, of a given vector on any vector is known as the component of vector on that particular vector. So if I have a vector which is represented as something like this, for example, this is a vector, and there is a vector, this is a B vector, I can say this is B vector, and similarly this is basically the C vector. Okay, so what if I take a projection? Now what is meant by taking projection? Taking a projection, basically this particular concept, ये वाला जो concept है, after studying about the dot products we will also study this particular projection concept. Okay, तो projection directly means कि अगर एक particular line को जिस वेक्टर के आपको प्रोजेक्ट करना है उसके ऊपर अगर कोई लाइट सोर्स दे रहे हो, अगर आप ऊपर से लाइट सोर्स को प्रोजेक्ट कर रहे हो, एंड दैट पर्टिकुलर लाइट सोर्स का जो शैडो बनेगा ना ऑन दिस पर्टिकुलर वेक्टर का जो शैडो बनेगा, दैट इज एक्चुअली नोन एज द प्रोजेक्शन ऑफ दिस पर्टिकुलर वेक्टर ऑन द गिवन वेक्टर. ओके, सो इफ आई टॉक अबाउट ए प्रोजेक्शन ऑफ ए वेक्टर ऑन बी वेक्टर, बेसिकली लाइट को ऊपर से ए वेक्टर के ऊपर से लाइट डालो, एंड द प्रोजेक्शन दैट बेसिकली मीन बी द शैडो दैट इज फॉर्म्ड बाय ऑफ द ए वेक्टर दैट इज फॉर्म्ड ऑन द बी वेक्टर. दिस बेसिकली मीन बाय द प्रोजेक्शन ऑफ अ वेक्टर ऑन ए वेक्टर ऑन बी वेक्टर. Now, similar to the concept of projection, there is basically concept of components. Okay, so if I talk about component, this basically means is vector ka what is the magnitude of projection in this particular direction. So for that particular thing, for the time being, you remember this particular result as, if I want to have the projection of A vector on B vector, I can write this particular A vector can also be written as, because if I see that in this particular situation that A vector, B vector and C vectors are mutually perpendicular, and if these both are mutually perpendicular, and if I form a parallelogram such that this particular parallelogram is formed such that if I name this parallelogram O, B, A and C, if O, B, A and C is a parallelogram which is formed by this particular joining these points, then I can write this A vector can be written as the this particular vector, that is basically the projection of A vector on B vector plus unit vector multiplied by unit vector of B plus projection of A vector on C vector multiplied by unit vector of C, I can write this by the basically the parallelogram law of addition. That means basically the projection of A vector on B vector times B ka unit vector plus projection of A vector on C vector times of C ka unit vector. I can write the A vector as like this. So what is basically the value of this and what is the value of this, and this particular thing is actually known as a component. This particular thing is known as a component of A vector on C vector, component of A vector on B vector. Now this particular component is actually got by the result of projection, that is known as A vector dot product with A B vector, and जिसके ऊपर प्रोजेक्शन फेंक रहे हो उसको उसका ऑपोजिट वेक्टर से डिवाइड कर देना है, ठीक है. फॉर एग्जाम्पल इफ आई एम टेकिंग द प्रोजेक्शन ऑफ ए वेक्टर, अगर मैं सॉरी जिसके ऊपर प्रोजेक्शन ले रहे हो, जिसके ऊपर प्रोजेक्शन ले रहे हो उस वेक्टर से उसको वेक्टर का मॉड्यूलस से डिवाइड करना है, ठीक है. और इस बार जो रिजल्ट है ना, आई विल टेक अप ऑन इन द टॉपिक ऑफ डॉट प्रोडक्ट. ओके, सो यू कैन सी दिस पर्टिकुलर रिजल्ट विच सिंपली रिजल्ट इज from, if I say this A vector जो modulus है, that is A, this length of this OA line is A vector mod of A vector, this is the modulus of A vector. Then if I see from the concept of, if I apply simple trigonometry from here, I can write modulus of A का cos theta is basically the projection of A vector on B vector का modulus. That means basically the OB vector का जो length होगा. Can I write like this? And what is cos theta? Cos theta is basically A vector dot B vector divided by modulus of both the vectors. Okay, so from here A vector and here A vector का modulus cancel होने वाला है. So from here what I get the result is basically known as the projection of A vector on B vector, that is basically A vector dot B vector divided by modulus of जिस vector के ऊपर projection कर रहे हैं. So from here I will get this particular result. Okay, times of B cap plus A dot C divided by C vector का modulus times of C cap. I hope this particular result is clear. Now why did I wanted to talk about the component of vector? So in basically situation, in many situations you will see that vector or any particular position vector is represented in terms of I, J and K vectors. Okay, now what are these I, J and K vectors? These basically are position vector, these basically are unit vectors, unit vector along x axis, along y axis and along z axis, and this is the basically the nomenclature that is basically followed in our mathematics syllabus of +2 level. So if I represent the unit vector which is along the x axis as I cap, the unit vector along the y axis as j cap, and the unit vector along the z axis as k cap, then I can represent this particular A vector as some x times of I cap plus y times of j cap plus some z times of k cap. So this particular way of representation of any vector is basically known as the component way of representation of any vector, where I, J and K vectors are basically mutually perpendicular vector or mutually orthogonal vectors. Okay, so I will introduce the term orthogonal vector. So from here what I can write and replace the concept of position vector as, if I have the point as x comma y. So what is x? X is basically the distance of point P from the y axis, and similarly the y is basically the distance of the point P from the x axis. So I can represent the position vector of this OP vector, that is basically the position vector of point P, can also be represented as xi cap plus yj cap minus point vector of that particular point as origin, that is basically 0 times of I cap plus 0 times of j cap. From here I will directly write this position vector as x times of I cap plus y times of j cap. So from here I get an important result that I can write any position vector in terms of component of I, j and k, such that if the points are given as x, y and z, then I can write the position vector of that particular point P as x times of I cap plus y times of j cap plus k times z times of k cap. If the point is basically in a 3D plane, if the point is basically in a 3D plane, okay, if the point is basically in a 3D plane and represented as x, y and z is basically the coordinate of the point, then I can write the position vector of point P as basically as xi cap plus yj cap plus z times of k cap. I hope this particular result is clear. I can write this particular result as something like this. Okay, so I hope this particular result is clear. Okay, now let us move on and understand another important thing from the component. If I know a component, I can also calculate the modulus value of this component directly, as if I have the position vector something like this x, y and z, then I can directly calculate the modulus value of this particular thing in terms of this particular components as x square plus y square plus z square, x square plus y square plus z square. This is basically the result that we get. How we are getting the result? If we see from the 2D plane, if we see from here, if I want to know the length of this particular line segment OP, what can I do? I can apply Pythagoras theorem from here, and I can do x square plus y square is basically equal to OP square. So from here I will get the OP is basically under root of x square plus y square. Now similarly, if we extend the discussion in 3D plane, we will get the result something which is like this. OP vector का जो length होगा from basically application will basically x square plus y square plus z square का whole का square root So from here I will get the basically the magnitude of the OP vector. I hope this particular concept is clear. Okay, now this types of concept will come very handy when you actually solve the question. Now this type of question I already took up in a previous lecture, where I have represented some vectors in terms of I, j and k, where I have already explained how to add the vectors in basically in this component ways. So whenever there is a vector addition and the vectors is basically represented in terms of component in I, j and k, then you have to basically add the individual component of the two vectors simultaneously. Okay, you have to individually add the individual component, that is I cap का component को I cap का component और दूसरा vector को add करना है. Okay, in this particular fashion, if you go on and add, and you get the result of what is known as the addition of two vectors. And similarly for subtraction, you subtract both the individual component, you get the subtraction. Okay, so with this, let us move on to the another important topic, that is basically known as the coplanarity. So basically I have already talked about coplanar vectors. So what is known as the coplanar vectors? So let me talk about coplanar vectors. So अगर मैं बताऊँ कि दो vectors are coplanar, the direct implication to the meaning is basically these two vectors actually lie in a plane. They lie in a plane. इन अ प्लेन. सो कोई दो वेक्टर तो ऐसा होगा जिसके लिए एक प्लेन एग्जिस्ट करेगा. सो इफ आई टॉक अबाउट देयर आर थ्री वेक्टर्स, इफ देयर आर थ्री वेक्टर्स एंड देयर इज अ प्लेन, और तीन वेक्टर एक ही प्लेन में लाई कर रहा है इन एनी फैशन, देयर आर थ्री वेक्टर्स, दिस इज ए वेक्टर, दिस इज बी वेक्टर एंड दिस इज सी वेक्टर, which is actually lying on this particular same plane. This is lying on this plane, and let us represent this plane का equation something ax plus by. Okay, and later we will talk about the equation of plane also in the chapter of 3D geometry. Plus cz is something equal to 2. This is basically the equation of a plane. Okay, अगर इस particular plane में तीनों वेक्टर सेम प्लेन में लाई कर रहा है, that is a unique plane में लाई कर रहा है, then we say these particular vectors are coplanar vectors. Okay, so from here if we will also see about the test of coplanarity when we study about the scalar trivial product. But before studying about the scalar trivial product, let us understand some theoretical results about coplanarity. So if I have to check about the theoretical explanation of coplanarity, so if we are given two vectors which lies in the same plane, then I can make another vector which also lies in the same plane in such fashion like this particular way. So I can write this: if R also lies in the same plane of this A and B vector, and A vector and B vector are coplanar vectors, then there exists a linear combination result of these particular vectors. Then I can write this R vector as equal to x times of A vector plus y times of B vector. I can write some linear combination for this R vector. I can write a linear combination for this R vector. Now from this particular result you can see an important result, that is whenever we added two vectors by the parallelogram law of vector addition, what we see that basically if I represent the diagonal and this addition vector is C vector, so from here I get the C vector is basically equal to A vector plus B vector by the parallelogram law of addition. So from here I can say that if it is also known that and we already know that कोई दो vector given है तो obviously same plane में lie कर एक plane में lie करेगा. So three vectors, and in this particular fashion we can relate these three vectors are basically as coplanar vector, because अगर ये दो vectors तो एक plane में lie कर रहा है, and if there exists a linear combination result of this A vector and B vector and which is related as C vector, then I can say this C vector is basically coplanar with A vector and B vector. I hope this particular result is clear. ठीक है, ये वाला रिजल्ट क्लियर हो चुका होगा. ठीक है, now this very important result. Okay, this is basically a very important result. Based on this particular result, let us try and solve out an important question. Okay, so question में क्या दे रखा है? Let us try and solve this question. So in this question it is given that there is a vector which is A, and this vector is represented as alpha times of I cap plus 2 times of j cap plus beta times of k cap, and this question was actually asked in JEE examination of 2008. So it is said that there is a vector which is given in component fashion is such in this way, and this vector actually lies in the plane of B vector and C vector, where B vector is basically given as I cap plus j cap and C vector is basically given as j cap plus k cap. Okay, now it is said that A vector is basically lies in the plane of B and C vector. So up till now whatever discussion we actually covered, actually जो discussion अभी तक कर रखे ना, तो उसके बेसिस में तो आप कोप्लेनरिटी का चेक कर सकते हो. बट आफ्टर वी स्टडी अबाउट स्केलर ट्रिवियल प्रोडक्ट विल गेट अ वेरी इंपॉर्टेंट रिजल्ट, दैट बेसिकली यहाँ तीन वेक्टर्स कोप्लेनर होता है इन द स्केलर ट्रिवियल प्रोडक्ट और द बॉक्स प्रोडक्ट इज बेसिकली इक्वल टू 0. So I will solve this question by two methods. If you are knowing about scalar trivial product, well and good. If not, you can skip that particular method. But before moving on to scalar trivial product, let us solve by the basic understanding of coplanarity. तो कोप्लेनरिटी का अंडरस्टैंडिंग क्या था? अगर मैं बताऊँ कि A वेक्टर इज बेसिकली कोप्लेनर विद दिस B वेक्टर एंड C वेक्टर, देन आई कैन राइट सम लाइक दिस एज लैम्डा टाइम्स ऑफ B वेक्टर प्लस म्यू टाइम्स ऑफ C वेक्टर. फ्रॉम हियर I can write like this because there exists some linear combination result of these two vectors. I hope this particular thing can be clear. Okay, so if I write like this, and then I will get, if I calculate the result, I will get mu lambda times of I vector plus lambda plus mu times of j cap plus and mu times of k cap. So from here, if I compare the result, that is alpha I cap plus 2 j cap plus this is beta k cap. So from here, what I get the result as lambda plus mu का जो value है, that is basically equal to 2. So from here, I also get the result as lambda is equal to alpha and mu is equal to beta. So what is actually asked in the question, that what are the possible values of alpha and beta? अल्फा और बीटा का क्या क्या पॉसिबल वैल्यूज हो सकता है. सो अगर मैं देखूँ कि अगर तो फ्रॉम हियर आई कैन ऑल्सो राइट दिस पर्टिकुलर थिंग एज अल्फा प्लस बीटा इज बेसिकली इक्वल टू 2. अगर मैं इस इतना तक क्वेश्चन को करने के बाद अगर मेरे को चेक करने के लिए बोला है कि व्हाट आर द पॉसिबल वैल्यूज, व्हाट आर द पॉसिबल वैल्यूज, ओके, व्हाट आर द पॉसिबल वैल्यूज ऑफ अल्फा एंड बीटा, व्हाट आई कैन गो एंड राइट, आई विल चेक ऑल द ऑप्शन. तो अगर मैं देखूँ अल्फा 2 है, बीटा 2 है, कैन दिस बी ए पॉसिबल रिजल्ट? नो, इट कैन नॉट बी पॉसिबल रिजल्ट. सिमिलरली अल्फा 1 है, बीटा 2 है, कैन इट बी पॉसिबल? नो. Can it be possible? No. So only possible result is basically alpha equal to 1 and beta equal to 1. So from here, the right answer to this question is basically option D. You can also solve this question by using the concept of scalar trivial product. You directly do this box product. You solve this box product as A, B and C का जो box product है, you directly solve this box product and equal it to 0. So how to solve this box product is basically to calculate the determinant value. If you want to know about this, okay, मैं calculate करके दिखा रहा हूँ कि कैसे करना है. Okay, this basically you can skip this if you not knowing. We actually write all the vectors in this along the rows and the individual components written. Okay, so these are the components of this A vector. Similarly, the component of B vector is basically 1 1 0. Similarly, component of the C vector is basically 0 1 1. So if I compute this matrix का जो determinant का value है and I equal it to 0, then I will get basically what is the condition of coplanarity. So from here, if I expand this particular determinant as first row as alpha is equal to 1 times minus 2 times of this is basically 1 okay. Similarly, plus 2 times of this will again be 1 and equal to 0. From here I will get the direct relation, that is alpha plus beta is equal to 2, which is the same relation that I was getting from in this particular fashion. Okay, so from here I will get the result also the question. So this particular can be also a method to solve this particular question. So if you are not knowing about scalar trivial product, stay tuned for the upcoming lectures where I will be talking about, after talking about the dot product and vector product, I will be talking about scalar trivial product. Okay, and then I will move on to vector trivial product and so on with the chapter. Okay, so stay tuned. Okay, so with this I come to the end of this question. Okay, now let us talk about another important concept, that is basically the concept of linear dependent and basically and linearly independent vectors. Okay, linearly dependent vectors and linearly independent vectors. So what is meant by linear dependence and linear independence? So linearly dependent, नाम से पता चल रहा होगा, there will be a linear relation and why there is a dependence relation. Okay, there. So if I have a relation, a vector relation equation such that involving all the vectors, if I say there are vectors a1, a2 and up to so on up to n vectors are there, and if I say x times of a1 vector, x1 times of a1 vector, y1 times of or x1 times of x2 times of, okay, so x2 times of a2 vector, and similarly I go on and xn times of n vector, and I represent this particular relation is equal to 0, is equal to null vector, basically vector addition, and the result will always be a vector. So if this result is equal to null vector, and then if I say that this relation is linearly dependent only and only when, if and only when at least one of x1, x2 and similarly x3 and xn is non-zero. कोई भी एक x1, x2 या x3 में से कोई भी एक ऐसे कांस्टेंट होगा which is non-zero, then in particular situation I can say that this particular vector relation is basically linearly dependent. Now similar to the concept of linear dependent and linear independent is very important concept when we study about linear algebra. Okay, so that means there can be a relation, there can be a linear relation in this particular vector equation. Now if I talk about linearly independent vector, and similar to the concept of linear dependence, then there will be no linear dependence. That means if I have this particular equation, if I have this particular vector equation and equal to null vector, then if these vectors are linearly independent, okay, if these vectors are linearly independent, and this can be only possible when all of x1, x2 and up to xn are all of equal to 0, when all of x1, x2 and x3 and so on up to xn are all equal to 0. In that particular scenario we get that the condition of linearly independent vectors. Okay, so from here I get some important results on on the linear independent and linear dependence results. So from here, if I go on and talk about what we have studied also, so if I go on and write some note from here, I can write a note that two non-zero, from here I can write a note on two non-zero vectors. Okay, like if I write there, if there are two non-zero collinear vectors, are always linearly independent. If I have two non-zero collinear vectors such that A and B are two non-zero collinear vectors and is equal to 0 vector, then I can say they are obviously linearly independent if A and B are non-collinear vector. So from here, if I write this particular vector equation result, then if these A and vector and B vector are basically non-collinear and non-zero vector, then they are obviously linearly independent. So this is basically the first important note. And similarly, two collinear vector are always linearly dependent. From the study, we already know that two collinear vectors can be represented in terms of some scalar multiple of another vector. So that means there exists a linear dependent relation between two collinear vectors. And similarly, if I say that any three coplanar vectors, if I have three coplanar vectors, A vector, B vector and C vector, then can I write this particular result that x times of A vector plus b times y times of C vector plus z times of C vector is basically equal to null vector? And then I can say that this where the x, y and z, where at least one of them are non-zero. ओके जहाँ पर एक्स वाई और जेड में कोई भी एक पर्टिकुलर होगा जो इसका वैल्यू नॉन जीरो होगा, then all of them are not equal to 0. Okay, so in that particular scenario this basically are coplanar vector. But agar these particular three vectors are non-coplanar vector, and in such case if I represent the relation of this particular vector equation, then I can say that those vectors are basically non-coplanar vectors. Then there will be a linear independent relation that exists between all these three vectors. I hope that particular was clear. Okay, that particular discussion was clear, and you have already taken up notes for that particular discussion. Okay, now let us try and talk about another important topic, that is basically vectors along the bisector. Now this is very important topic. Okay, this is very important. So अच्छे से सुन लो इस particular बात को, ठीक है. क्वेश्चन में हमेशा आपको पूछेगा, कभी कभी क्वेश्चन में पूछ देता है कि द वेक्टर along the bisector of this particular vectors is given as this. ठीक है, इसके बेसिस में हम क्वेश्चन करेंगे अगला क्लासेस में. ठीक है, इन द अपकमिंग क्लासेस वी विल सॉल्व क्वेश्चन ऑन दिस पर्टिकुलर कॉन्सेप्ट, बट ये वाला जो कॉन्सेप्ट है इज वेरी इंपॉर्टेंट. ओके, सो लेट अस स्टार्ट एंड ट्राई टू अंडरस्टैंड द कॉन्सेप्ट. अगर किसी को पूछोगे ना वेक्टर along the bisector and if you do this particular thing, okay, then many of them will tell like this, that if you complete a parallelogram and write this addition vector, then this is basically a vector along the angle bisector. This is very wrong result. This is very wrong result. ठीक है, this particular vector is not the vector along the angle bisector. बट ये वाला वेक्टर एंगल बाइसेक्टर तभी हो जाएगा जब ये ए वेक्टर का मॉड्यूलस 1 हो जाए और बी वेक्टर का मॉड्यूलस भी 1 हो जाए. इन दिस पर्टिकुलर सिचुएशन द वेक्टर दैट इज अलोंग दिस द यूनिट वेक्टर दैट कैन बी फॉर्म्ड अलोंग दिस पर्टिकुलर एडिशन वेक्टर ऑफ बोथ दिस यूनिट वेक्टर, बोथ दिस ए यूनिट वेक्टर एंड बी यूनिट वेक्टर is the vector which is along the bisector. I hope this particular this concept is very clear. So if I have two unit vectors basically like this, a cap, and over here as b cap, and if I want to know if I b cap, okay, over here b cap, this is basically b cap. Okay, so if I want to know the vector which is along the angle bisector of this particular vector, so क्वेश्चन में क्या होगा पता है, क्वेश्चन में आपको कोई पर्टिकुलर साइड दे देगा. फॉर एग्जांपल दिस इज साइड विच इज ए बी वेक्टर एंड ए सी वेक्टर दे देगा, एंड आपको पूछेगा कि एंगल बाइसेक्टर के अलॉन्ग एक यूनिट वेक्टर निकालो. तो सबसे पहले क्या करना है ना, फर्स्टली वॉट एवर साइड इज गिवन इस वेक्टर के अलॉन्ग एक यूनिट वेक्टर निकालो, सिमिलरली इस वेक्टर के अलॉन्ग एक यूनिट वेक्टर निकालो, एंड देन कंप्यूट दिस पर्टिकुलर रिजल्ट, एंड देन कंप्यूट द पर्टिकुलर रिजल्ट दैट इफ यू वांट टू फाइंड द यूनिट द एंगल बाइसेक्टर, यू वांट टू फाइंड द एंगल बाइसेक्टर लाइक दिस फैशन. अगर आप एंगल बाइसेक्टर तभी निकाल सको क्योंकि पैरेललोग्राम में जो डायगोनल होता है वो एंगल बाइसेक्टर नहीं होता है. बट इफ द पैरेललोग्राम इज स्पेशल फॉर्म ऑफ पैरेललोग्राम दैट इज रॉम्बस, दैट जहाँ पर दोनों साइड्स सेम है, अगर दोनों कॉरस्पॉन्डिंग साइड्स अगर सेम है, देन द पर्टिकुलर डायगोनल इज अलोंग द एंगल बाइसेक्टर, देन द पर्टिकुलर डायगोनल इज अलोंग द एंगल बाइसेक्टर. सिमिलरली विच इज अ कॉन्सेप्ट इन रॉम्बस का जो डायगोनल होता है दैट इज अलोंग द एंगल बाइसेक्टर. ओके, सो फ्रॉम हियर आई कैन राइट द वेक्टर अलोंग द एंगल बाइसेक्टर एज फॉर एग्जाम्पल इस वेक्टर को मैं एक्स से लिख रहा हूँ. सो इस वेक्टर को मैं एक्स से लिख रहा हूँ. आई कैन राइट दिस एंगल बाइसेक्टर का जो वेक्टर है, लेट अस राइट दिस एंगल बाइसेक्टर का वेक्टर है, उसको मैं कैसे लिखूंगा, दिस पर्टिकुलर वेक्टर कैन बी रिटन एज ए वेक्टर का मॉड्यूलस a vector unit vector along a direction plus unit vector along b direction, that is a cap plus b cap इसको डिवाइड कर दो, किससे, इसका मॉड्यूलो से डिवाइड कर दो, देन वी विल गेट द यूनिट वेक्टर विच इज अलोंग द एंगल बाइसेक्टर. नाउ दिस थिंग विल गिव मी यूनिट वेक्टर along angle bisector. I hope you will remember this result. This vector, this thing will basically generate me the unit vector along the angle bisector. So similarly, अगर मेरे को पूछा जाए कि A B और A C दे रखा है along the vectors and I have to find the angle bisector का unit vector, then what we'll do, we'll first find the unit vector of AB, that is A unit vector, and then we find the AC ka unit vector, that is B cap, and then we will do one important thing. For to get the unit vector along the angle bisector, we will do this particular computation, that is A cap plus B cap whole divided by the modulus of this particular addition vector, then we will get the result of unit vector along the angle bisector. So I hope this particular concept is clear. Okay, so let us try and solve out some important question with this. Okay, so from the question it is said that in a triangle, for example, a triangle is given such that A, B and C at the vertices of the triangle, then from here we see that AB vector is given as 3i cap plus, this is basically given as 3i cap plus 4 times of k cap. Similarly, AC vector is given as 5i cap minus 2j cap plus of 4k cap. Okay, so if this particular result is given and these are basically the sides of a triangle of AC, then I have to find the length of the median. So basically from the concept of section formula, can I write the vector along the median, that is AD vector? Can I write this AD vector as AB vector plus AC vector divided by 2? Because the AD vector, we basically divide this line segment BC in the equal proportion, and that is equal to 1:1, that is basically the midpoint division. So from here AD का जो vector होगा वो मैं ऐसे कुछ लिख सकता हूँ. So AB vector plus AC vector divided by 2. So from here if I calculate the computation of this addition, I can get 8 times of I cap minus 2 times of j cap, okay, plus of 8 times of k cap and whole divided by 2. So from here the result I will get as 4 I cap minus j cap plus 4 times of k cap. Now what is actually mentioned in the question, that is basically to find out the length of the median. So what is the length of the median? This is basically the length of the median which is actually asked in the question is basically equal to the modulus value of this AD vector. So if I calculate the modulus values of AD vector, and I already talked about कि अगर AD कोई एक वेक्टर है जिसको कंपोनेंट के फॉर्म में रिस्पेक्ट किया गया सच एज आई कैप, जे कैप एंड के कैप, देन दैट पर्टिकुलर वेक्टर का जो मैग्नीट्यूड है कैन बी इजीली कैलकुलेटेड बाय इंडिविजुअल कंपोनेंट को स्क्वायर करो, ऐड करो, स्क्वायर रूट ले लो. ठीक है. सो विद दिस इफ आई कैलकुलेट दिस इज 16, 4 का स्क्वायर इज 16 plus 1 का स्क्वायर इज 1 minus 1 का स्क्वायर इज 1 and then 4 का स्क्वायर इज 16 over here. So from here I get the result which is equal to under root of 13 units. So from here I get the right answer to this question is basically option number D. I hope this particular discussion is clear. So with this we come to the end of the lecture. Okay, so today's lecture is basically end over here. So with this I complete the most important particular portion of basically algebra of vectors. Okay, so in the upcoming lectures we will start talking about the product of vectors. Okay, and we will also solve some important question that is basically exam point of view, which is most important in terms of exam and also understanding purpose. Okay, so I will take up some important question to illustrate my words further. Okay, ना क्वेश्चन में क्या होगा पता है, अब ऐसा टाइप का क्वेश्चन मिलेगा जहाँ पर इन अ ट्राइंगल देयर विल बी इन्वॉल्विंग अ ट्राइंगल, दे हैव टू कैलकुलेट कोई पर्टिकुलर स्पेशल पॉइंट ऑफ अ ट्राइंगल दिया रखा होगा, एंड डिपेंडिंग ऑन द स्पेशल पॉइंट यू हैव टू कंप्यूट सम वेक्टर एडिशन एंड वेक्टर सब्ट्रैक्शन और मे बी वेक्टर प्रोडक्ट्स कैलकुलेट करना पड़ेगा. ठीक है. फॉर दैट पर्टिकुलर रिजल्ट यू हैव टू अंडरस्टैंड द बेसिक्स बहुत अच्छे से. ठीक है, बहुत अच्छे से आपको बेसिक समझ में आना चाहिए. ठीक है. इफ यू आर नॉट थॉट विद द बेसिक देन यू वोंट एबल टू क्रैक दोस क्वेश्चंस. ओके, जो क्वेश्चन आपको ट्राइंगल के बेसिस में आता है. ठीक है. सो आई विल टेक अप दोस क्वेश्चन इन द अपकमिंग क्लासेस. सो स्टे ट्यून विद दिस लेक्चर्स एंड सब्सक्राइब टू माय कंटेंट. ओके, सब्सक्राइब टू दिस पर्टिकुलर चैनल, and also if you like this video, like and share it among all the students, okay, among all your friends, so that it reaches all the needy students who want them. Okay, these lectures are basically free of cost and I am providing every detail that is basically required to crack the JEE Main, JEE Advanced, WBJ examination or your CBSE board examination or even any other state competitive examination. For any examination, if you talk about and this particular lectures on mathematics or any examination which is involved the syllabus of mathematics at +2 level, these lectures are sufficient for it. Okay, and simultaneously I am providing the notes in the description box. Go download those notes and start making your own short notes as well as good proper notes, and also solve those questions once again if you want to have good understanding of each and every concept, okay, in detail. So with this I take a leave.